Chapter 3, Section 2 is computing with multi-digit decimals. The objective is students will perform operations with multi-digit decimals. I'm thinking we're probably going to add, subtract, multiply, and divide, but that's just a guess. We'll see where it takes us. The pacing guide says that this is going to be a 2-day lesson, so let's hurry up and get started because we have a lot to cover. The interstate highway system is a network of highways that connect states across the country. The Federal Aid Highway Act of 1956 was passed to expand the current interstate highways in the United States. From 1956 to 1962, during the construction of the interstate highway system, there were about 14,300 miles of roads built. In a recent year, there was 3.28 times as many roads that were in use in that part of the interstate system. Write an expression that can be used to find how many miles of road are part of the interstate highway system and explain why you chose the operation you did. These are the kind of things we're going to be learning to do in this chapter. First, we're going to learn to add and subtract multi-digit decimals. The textbook says you have already added decimals to the hundredths place, and you can apply the same rules when adding decimals to the thousandths place. First thing we're going to do is align the decimal points just like we've already done. Then we're going to annex zeros just like we've already done. And then we're going to add them up and bring the decimal straight down. And it's going to look something like this. So right here you can see they align their decimals, one right on top of each other. And they annexed in the zero right here. That zero was not there in the original number, which is over here, but they put a zero there because they needed a placeholder. Remember, you can add zeros at any point after the decimal. Add as many zeros as you want. They're already there. We just don't write them because we don't need them. But those zeros go on and on for all time and eternity, and they represent absolutely nothing, because that's what zero represents, nothingness. From there, you're going to add the numbers just like you would if it was a whole number. Only difference is now that decimal is going to come straight down, and of course you're going to want to circle your answer. So the final answer is, well, I'm not going to bother typing that in because they gave it to us right here. I mean, it's 66 and 544 thousandths. Easy math. Anybody can do this. Subtraction. It's going to work the same exact way, only now we're going to have to do some borrowing. We're going to align our decimals just like they did before. We're going to annex in zeros just like they did before. Only now we're going to subtract. Let's go ahead and show where they got that from. Hold on, because there is some borrowing there. I know some of y'all struggle with that. So what they did here for this problem, I'll get my pen working, is they started off by borrowing. They said 0 minus 6 they couldn't do, so they took that 4, made it a 3, and made that 0 a 10. 10 minus 6 was 4. Then they said 3 minus 8. Well, we can't do that either, so they took that 9, made it an 8, and took its value and made that 13. 13 minus 8 is where the 5 came from. 8 minus 3, totally doable. That was 5. And then, 2 minus 5, they couldn't do that either, so they made that 3, whoops, wrote that wrong, into a 2, and this 2 became a 12, and 12 minus 5 is 7, 2 minus 1 is 1, and that is where they got the 17.554, also known as 17 and 554 thousandths, which is what we would put in here if we were going to do that. Don't forget, you have to bring your decimal straight down and circle your answer to make it easy to find. This right here, guys, that's showing your work. That's the kind of stuff I'm going to look for on your homework tonight. If you go straight from this problem here to an answer, I'm not going to give you credit for it because you're not showing me all the steps I need to see. For a talk about a question, they asked, how does annexing a zero help you to add and subtract numbers easily? Well, if you go back and look at where we did it here, we annex a zero in here, and it holds a place. It's a placeholder just to help us say, well, you know what? There's something there. I'm taking 6 away from something. So it really does indeed help us to keep all of our numbers aligned and straight. All right, folks, now it's your turn. You got a problem right here. Take and pause the video, solve it, and check and see if you get the right answer. Go. Did you get it right? Well, let's find out. Now, they started off by suggesting that we make an estimate. For their estimate, what they would say is, well, let's see, 23.3, that's going to be about 23. 14.9, that's going to be about 15. And when you add those two numbers together, 23 plus 15, that's going to be 38. So our ballpark answer should be something around 38. Now we're going to solve it. So moving through, you can see where they've taken and aligned the decimals already, right here. Next step, annex zeros is needed, which you see right here. And from there, it's add and subtract normally. Bring the decimal straight down. You can see they did some carrying here. 9 plus 3 was 12. The 2 went down. They carried a 1, making that 1 plus 4 plus 9, which was 14. 4 went down, carried the 1. 1 plus 3 plus 4 was 8. And then, of course, 2 plus 1 became 3. From there, the answer is exactly what they ended up putting right here, so no reason to do it again. Be sure you're checking your answers, though, and be sure you're circling them so I know where to find them on your paper. So why is it a good idea to estimate your problems before you solve them like we did here? It lets you know if you're in the ballpark. If you end up with a final answer that's way far off from your estimate, we call that a clue in police work that you might have done something wrong and need to go back and check your work again. Alright folks, now it's going to be your turn. Pause the video, solve this problem, check your answers, and let's see what we get. Now first thing I'm going to do is align my decimals. 142.687, also known as 687 thousandths, plus 54, the decimal goes right there, 9, that's 54 and 9/10. I got holes here, so I'm going to annex in some zeros where those holes here are, and then I'm going to add them up. 7 plus 0 is 7, 8 plus 0 is 8, 6 plus 9, that's going to be a 15, carry the 1, 1 plus 2 plus 4 is going to be 7, 4 plus 5 is going to be 9, and the 1 comes down, and your decimal comes straight down for 197 and 587 thousandths. So let's plug it in. 197 and 587 thousandths. Check our answer. Our answer checks well. All right, now it's your time to do this again. And the first thing I want you to do is make an estimate, just like we did last time. After you make the estimate, I want you to solve it. And then when you solve it, check your answer, see what you get. Go. So what did you end up getting? Let me start off by saying for me, 163.45 is about 163. 85.3, that's about 85. And when I subtract those from each other, let's see, that's going to give me 83.78, I believe, is going to be the answer. Check my answer here, and wonder what they ended up getting. Hold on. Ah, I see. They decided that they were going to round to tens, which is okay. It makes the math a lot easier to do. They made 163 to 160, 85 to 90. That gave them 70. Now let's see how close that 70 is to the real answer. So when we continue through this, let's keep going. We're going to take and annex in zeros as needed. The decimals are already aligned. We're going to subtract normally. Boy, they did a bunch of borrowing there to do that. And when they finish the final answer, no reason to type it in here because it's already written there. Easy math. Be sure you circle your answer before you send it to me. Alright, here's another one for you to try on your own. Pause the video, work the problem, check your answers. Go. When I work the problem, I'm going to start off with my first number, 283 and 74 hundredths. I'm going to subtract from it 127 and 347 thousandths. My decimals are aligned. I'm going to annex zeros as needed. Now it's going to be time to borrow. So that 4 is going to become a 3, so this will become a 10. 10 minus 7 is 3. 3 minus 4, can't do that. So that 6 is become, or 7 become a 6, and this become 13 minus 4 is 9. 6 minus 3, that's 3. You just heard my frozen burrito beep in the microwave. And now 3 minus 7, I can't do that. So I'm going to make that a 7 and this a 13. 13 minus 7, that is going to end up being 6. And then 7 minus 2, that's going to end up being a 5. 2 minus 1 is a 2. My decimals are aligned, 156 and 393 thousandths. So I'm going to come back over here, 156 and 393 thousandths. Check your answers. Easy math. Anybody can do this stuff. All right, let's step up our game a little bit now. They've given you a little more challenging problem. This one you don't see a decimal in, but remember your decimal is always there, as you can see right here. You just have to annex in zeros after it. So you pause the recording, make your estimate, and after your estimate, solve the problem and see what you get for an answer. When I would work this one, I'd leave the 25 as 25 and the 17 point whatever, I'm going to change that to 17. That's some pretty easy math to do. 25 minus 17, the answer is going to be 8. Check our answer. That checks with what they did. So a ballpark answer should be somewhere around 8. Let's take a look at the next part. So they're going to they already aligned the decimals, and you can see they annexed in 3 zeros. After that, there's going to be a bunch of borrowing going on, and you can see the borrowing they did there. After they borrowed, they ended up with the final answer of 7 and 531 thousandths. Make sure you're circling your answer, and there's no reason for us to put it in there because, I mean, they gave it to us, for crying out loud. Now it's going to be your turn again. Pause the video, work the problem. Let's see if you get it right. All right, when I work the problem, I have 43 with a decimal that's right there. It's invisible. And then we're subtracting from it 12 and 67 hundredths. I'm going to annex in my zeros as needed, and then I'm going to start borrowing. Now on the borrowing, it's a little bit tricky because you got 2 zeros here. I know that one's going to end up being 10. This one, I'd like to be 10, but it's not. I have to take away from that. So let's take and borrow and make that 3 into a 2 and give that its 1 value over here, making that a 10. But we borrowed from that 10 to make this one, so that one's now going to become a 9. 10 minus 7 is 3. 9 minus 6 is 3. There's that decimal. 2 minus 2 is 0. 4 minus 1 is 3. Your final answer is going to be 30 and 33 hundredths. Go back to our problem. 30 and 33 hundredths. Check our answer. The answer checks. Good job. And now it's time to multiply decimals. Remember, when multiplying a decimal, you're going to multiply it as you would with whole numbers. You don't align anything starting off. To place a decimal point in the product, you find the sum of the number of decimal places in the factor. That's the things you're multiplying. Factors, fancy word for saying things you're multiplying. And the product is the same number of decimal places, the product, of course, being the answer. If there's not enough decimal places in the product, we're going to annex in some zeros, and then we're going to put it to the left of the first non-zero number. So with that, we're going to move through the steps and see what happens. You've got 14 thousandths times 3.7. From here, notice my decimals are not aligned. You don't align the decimals when multiplying decimals. You just justify them and multiply just like you would if you had whole numbers. So 7 times the 14 gave you 98. 3 times the 14 gave you the 42, and of course remember you move one space over, and they just stuck that 0 in as a placeholder because you move one place over, and when you add those up you get 580. Now we're going to count how many spaces from the right the decimal is in the product, excuse me, the factors, or these things up here that you're multiplying. So we're going to count 1, 2, 3, and 4. So we have to move it 4 spaces from the right of the answer. But we only have 3 spaces. What does that mean? That means we're going to have to put a 0 in right here so that we can have that decimal 4 spaces from the right of the answer. And of course, you need to be able to circle your answer to make sure that I can find it when I'm looking at it for it on your papers. This is where we're going to stop with part 1 of this lesson. Come back for part 2, And let's see what they give us here. Nah, I think we're gonna, let's see, when you add subtract decimals, you need to align them. When multiplication decimals are not aligned, why don't you need to align them? Because it just doesn't matter. When you come back for part 2, we're going to give you an opportunity to work the multiplying decimals, and then we're going to see what else the textbook has to offer. See you in the next lesson.